So my name is Wang. I grew up in China and moved to Canada at some point, I don't remember. And I went to college there. I studied mostly math during undergrad and some statistics. And I came here to Ann Arbor about 2 years ago to do a PhD in stats. Now it's my second year. And my research is about high-dimensional statistics, machine learning, and graphical models. And what else? My role in the team, mostly I'm working with Professor Al Hero and Yang Chen, who were also on this project, and mostly applying some of the stats or machine learning methods to this particular data, basically. So my research before this, my research is mostly like theoretical or more on the stats or math side. So I always want to find some applications or real world problems where I can apply those methods, right? So, and this Solstice project has those features, right? It has data that is where my methods developed are suited for, and also has real world impact, right? It has a lot of impacts on either Earth or physics or astronomy, stuff like that. That's why I joined this project. And I guess my goal in this project is basically to see whether those theoretical methods can actually apply to real world problem, basically. Yeah, I like to run. Well, before I play video games, but now I'm sort of more into running, outdoor activities, those stuff. So usually I start by so in the morning, I usually looking at the data, forget about all the methods, just to look at what the raw data looks like, and whether there's I think this project involves a lot of sort of handling or manipulation of the data before you can go into the actual method. So I do that a lot, and after making sure the data is fine, no missing values or no outliers, those stuff, I then apply the method I want to apply. I develop in theory and to those data. And sometimes it could take a long time to even run the method. So I just wait for the results to show up on my computer or something. And then I just check whether, so there's something about the project, for example, the physics perspective or astronomy perspective that I don't always understand. So I sometimes talk to people in, for example, the space engineering department to see what these results mean, right? Basically. Yeah, so I like those kind of collaboration, inter department or something. Yeah, that's pretty much it. So basically grab the data, apply my methods on it, and see whether I can or somebody else can interpret the results. Yeah. So mostly it's imaging data, or they call it magnetogram data of the sun. So basically some spacecraft on the universe take a picture of the sun, take a picture of part of some regions of the sun, and they sort of transform it to, it's basically image. Yeah, I would say, yeah. Mostly imaging data, and we also have some other data which are features that the physicists calculated from those images. So it's basically image data. So for someone who wants to do, let's say, a PhD or just doing research in general, so my advice would be to either during undergrad or some earlier stage of the educational career, try some research projects with either a professor or with some like of your classmates and see whether you like it, basically. So it's not, yeah, it's not, I would say it's not always fun. So sometimes it could be really like frustrating and you could under a lot of like stress. But as long as you are really interested in those kind of research or those kind of stuff you work on, you will be okay. So during my undergrad, my background is a little bit like different. It's in math, and I have some internship experience in undergrad, but those are in a whole different industry. It's in insurance and finance industry is completely different. But I guess in general, so because during either those internships or my studies, so I have to, for example, work on data a lot instead of just something in theory. That prepared me like those kind of skills of, for example, manipulating data and paying attention to details of the data that could like break your methods. Yeah, but not much like directly related to this project, I guess. But in general, I think those help. Good question. Yeah, I don't know. So at the beginning, I just wanted to work on some real stuff instead of like very abstract like math. So I'm not like particularly like looking for like space or physics related project, but this one I just feel like I could really make an impact on the real world because many aspects of the solar activities or the sun could have a huge impact on Earth, on people's life on Earth, basically. So some of my research is related to the estimation of like how dependent some variables are. So if we consider those variables are the pixels in those imaging data I just mentioned, and so my method could apply to estimate those like dependency structures. And what we found is that we could sort of use those dependent structures to predict or discriminate between two different solar activities. And we actually found that very successful, meaning that the method could really tell. So if you give the method like two different pictures of the sun, and it could actually, to some degree, tell that there are like different solar activities. I guess I will just keep maybe modifying the method such that it will more like suited for this data set.